Distinguished ladies and gentlemen, let us have a look at multiple integrals. And let us have a look at this question that evaluate the integral from 0 to 1 and also the integral from 0 to 2 y squared x, close the bracket, dy dx. Now, ladies and gentlemen, for us to evaluate this double integral, because we can see we have to differentiate, we have to integrate, not differentiate, I'm sorry, we have to integrate it twice. We have to integrate the first time, then we have to integrate the second time. So, ladies and gentlemen, in multiple integrals, what we shall look at mostly is that we shall look at the first, we have to integrate with respect to y first, then with respect to x. So we will have also to integrate from 0 to 2 first, then we will also have to integrate from 0 to 1. Now, ladies and gentlemen, let us proceed to solve this function that we have to integrate from 0 to 1. What we will do is that we will integrate this function first, that is y squared x, from 0 to 2 first. We will have to integrate from 0 to 2 first. That is with respect to y. That means we will keep x constant. That means we will have y raised to power 3. Because in integration, we are only considering y. That is with respect to y. So that means we shall have y raised to power 2. We add 1 to the power and we divide with the new power. So if we add 1 to the power, that means 2 plus 1 is 3. So this is the 3 that I have. Then I also divide with the new power, which is 3. Then I keep x constant. Then I have differentiated with respect to y. Partially differentiated with respect to y. Then I will have the limits from 0 to 2. Then we have dx. Now, ladies and gentlemen, that means I have to fix the limits, that is from 0 to 2 in y alone, but I will keep x constant. That means I will have the integral from 0 to 1 into y cubed over 3 from 0 to 2. Then I will have x constant. I will have x as constant. Then we have dx. I will have dx. Now, if I fix 2 here, instead of y, I will have 2. So it will be 2 cubed. It will be 2 cubed over 3 minus 0 cubed over 3. Then minus, not even minus, but times. I have finished this. I am through with this. Then I will just have my x there. Then I will have the integral from 0 to 1. Then I close with the bigger bracket. Then I will have dx. Now, 2 raised to power 3 is 8. So I will have 8 over 3. Then 0 raised to power 3 is 0. Divided by 3 is 0. Therefore, this one will be minus 0, of which it will be 8 over 3. Then I close the bracket, we have x dx. Then I will have the integral from 0 to 1 here. Now, I will also integrate this with respect to x. I will integrate 8 over 3x with respect to x from 0 to 1. Now, if I integrate this, I will have 8 over 3 is a constant. So I will put it outside the integral sign. Then I will have the integral from 0 to 1 x with respect to x. If I integrate x with respect to x, Then I will have 8 over 3 here outside, then into, I will have x squared, because this is raised to power 1, and therefore I will add 1 to the power and also divide with the new power. And that means we shall have x raised to power 2 over the new power, which is 2, and I will take the limits from 0 to 1. Then that is, we proceed. Let us proceed to solve this. Let us proceed to solve this. We will have 8 over 3 into, I will, instead of x, I will have 1, then squared over 2 minus, instead of x, I will have 0, 0 squared over 2, close the bracket. So I will have 8 over 3 into a half. This one will be a half and this one will be 0. So it will be 8 over 3 into a half. And this is, if I multiply 8 over 3 with a half, that means by 2, 1, by 2, 4. And finally, our answer will be 4 over 3. That is how you can solve a double integral. Like now, ladies and gentlemen, how I wish that you could subscribe to my YouTube channel, you could like, you could share and comment. Thank you.